Hi, I'm Furong. I'm gonna talk about aligning AI on the fly today. So we know alignment is very important. There is this misalignment that we wanted to steer AI systems that are misaligned to what humans' intended goals, preferences, or ethical principles. What I really have in practice is, in reality, models are getting bigger and more capable as models get bigger, but I don't have a lot of GPUs. So what I really want are probably like a 400 billion model, but in reality, what I can afford to train is probably a 7B, if I'm lucky, a 7B model. So what can I do, right? Is it possible that I could align large language models without ever having to train them? That's my wish list. Now, what if you have multi-objective that you wanted to align your language models to? For example, you wanted language model to be harmless. You also want it to be helpful, right? So can you get both, or can you achieve more than two different objectives? But intrinsically, there is some trade-off when you think about language models, right? So there is this helpfulness and the harmlessness. So it seems like there is an intrinsic trade-off when you're training these models, as you show in this. So my objective here is that, can we have efficient multi-objective alignment without ever having to retrain? Now, you could also imagine that if you have a base language model, right, you have to cater to many different preferences that are personalized. In reality, you cannot really train all these models to cater to different preferences. So maybe the dream is like, can you have one model that caters to all? So that's basically the motivation why we wanted to have a language model that is able to, be aligned on the fly. So what do? We resort to like a reward-guided decoding, which essentially uses a base language model and together with an external reward function. So this reward function will guide you through different preferences, and you could have multiple reward functions to guide different objectives, right? So the next token sampling becomes the problem here because what you have is essentially like a next token kind of prediction or reward function, but in reality, you only have the trajectory level reward. So what happens before, people just ignore this no matter what and just use an outcome reward model to guide the generation of the next token, which is not correct. So that's why we figured out maybe the right way to do it is to actually do the completion, right? To actually predict what the language model will be doing and then use the entire trajectory to understand the reward function. And using that, we essentially see a huge boost in terms of the utility and in terms of the alignment. But although this is correct, it is very slow. So what happened is, if you wanted to generate response with 500 tokens, will take 14 hours, which is essentially just unrealistically too slow. So what happened later on, we come up with an autoregressive reward model, which generates a next token reward directly and reduces the 14 hours to 20 seconds. So the idea of it is very simple, just reparameterization. Just parameterize your reward function as some kind of logarithm of probabilities, and essentially summing over all the tokens. So what happened is, now with this parameterization, we believe that it could even alleviate reward hacking because you are shrinking the function class. So putting more priors into your function class, so using the same amount of data, hopefully you are less susceptible to this reward hacking problem. Training is very simple. You only need trajectory level preference data, just like how you would train normally a reward function for outcome reward function. And inference is even more simpler and very efficient. Just do next token prediction right away. So here is a visualization of showing how you can be very efficiently doing this next token prediction using this reward. Well, show you some experiment results, right? So first of all, it matches the training time alignment baseline and outperforms state-of-the-art test time alignment baselines. It's also very efficient. And what's really impressive is that it can actually do weak to strong guidance, meaning like without fine-tuning the large base language model, you could actually guide a very large language model using a very small reward model. I think it's pretty interesting. And of course, we also show that there is multi-objective alignment, that you can, sort of fine-tune, the ways that you put into different objectives. So finally, I just wanted to conclude that I advocate for this kind of test time alignment so that you're not being preemptive, or you do not necessarily have to compromise these kind of usability. Using this test time adaptability, you should be able to just adapt on the fly and then being able to defend against these adaptive attacks. So with that, I'll just conclude by saying that I believe that there is a cat and mouse game in the safety of generative AI, because even if you think about safety alignment itself could be exploited by attackers. Recent papers showing you some of that result. With that, I'll just conclude. Thanks.